Hello friends, I am Nitesh Kumar and welcome to my YouTube channel. Today we have a topic that how to rectify the DC earth fault from your substation or anywhere in the control system of your power plant, your substation, anywhere. Okay, if it is occurred. So in my a little allowances in Hindi, मेरे हिंदी दोस्तों अगर आप इस वीडियो के हिंदी भाषा में देखना चाहते हैं तो जो लिंक जो है डिस्क्रिप्शन बॉक्स में दिया गया है सेम वीडियो आप हिंदी में देख सकते हैं। आई मेड ए सेपरेट वीडियो मैंने बनाया उसके लिए, ठीक है। सो कंटिन्यू। Then I received many comments from my viewers that how to rectify the DC earth fault if it is occurred in the substation or in the control system, because already I have made a video on this topic, but in that video I couldn't explain that how to rectify that, how to clear it. Okay, in that video I had explained that how would you identify that whether the earth fault is there in your positive lead, positive wire, or in the negative wire. Suppose there might be the positive earth fault or negative earth fault, it's not clear, then I had clearly doubt in that practically I had shown with the multimeter in that video. So if you have not seen that video, please watch that video. The link is given in the description box and then continue, I would suggest. Okay, so here in this video, suppose I will suggest you to take a multimeter. You need to use a very good multimeter, a branded multimeter, so that there will not be any error in that. It will show the perfect value and there is a very less chance of the incident. Okay, and also you have to use like this. Suppose you don't have to hand this multimeter over to any other friend hand, and you have to measure the supply, because in that case this may blast and that may cause incident and that may damage your hand or your friend's hand. Okay, so you have to place the multimeter with the help of this pad given. This is like this will be a stuck. Okay, with the help of this will stuck anywhere, so you have to place this anywhere and then you have to catch the probe and then you have to use it. Okay, so be with the safety. I will suggest you personally, because if you are not caring of your safety, this might cause many problem. Okay, so let us continue. So consider that there is a 220 volt DC supply source 1 I have taken for an example, and there is a isolator mechanism box. Okay, if the fault occurred in the switch yard, then for that I have taken example. So this is the mechanism box of isolator, and this side the 220 volt DC supply source 1. So this might be your DCDB also. In substation control room you would have seen that DCDB source 1, DCDB source 2, like that it is there. So this red color is the positive wire and this blue color is the negative wire. Okay, just consider it. Okay, then in normal condition, suppose if your DC system is healthy, then in that condition if you connect the probe of the multimeter across this two lead, positive and negative, like this in the picture it is shown, then you will get complete 220 volt DC. Theoretically you will be getting 220 volt DC, but practically this might be 222 or 225, or it might be 218 volt, 215 volt also. It depends upon the charging of your battery and your charger and your DCDB source. Okay, but theoretically just take an example of theory value. Okay, so that we can understand better. But what if we connect this red color probe of multimeter in the positive lead and this negative to the ground? That means with respect to ground, what will be the voltage in the positive lead? There you will get the half of the potential, full potential. That means if the 220 volt DC supply source 1 is there, that means you will get 110 volt DC positive. Okay, and when you will connect, see here, this is wrong. Okay, here it is connected wrong. This red color probe will be connected here. Okay, in this blue color lead, that means in the negative, and this black color will be connected to the ground. Then in that condition you will get minus 110 volt DC. That means half of the full potential. Okay, but here it will show the negative sign. Okay, just please ignore this picture, this is in a wrong connection. Okay, if you do like this, you will get the half potential, but this will not be negative, it will show positive. But you are measuring the voltage in the negative lead with respect to the ground, then the connection should be like this red color lead should be connected here in this negative wire, and then this black color should be taken as a reference. This will be connected to the ground. Okay, so why you are getting this half, that means half potential 110 and 110 in lead. This is a matter of topic, this is a matter of a theory part, that if you have not if you don't know about it, then I'll make a good video about this. The link will be given in this description box itself. Okay, but just continue to this topic itself. Okay, but in case suppose the fault occurred in the positive lead anywhere in the circuit, anywhere from this DC supply source, from this DC DV to this isolator magnetic box, or to the circuit breaker or indication circuit or whatever it might be. Suppose the fault occurred here anywhere, then in that case you can say that there is a fault in the DC, right? Positive, right? Then you can say that positive DC earth fault is there. Then if you measure positive to the ground, then how much it will show? This will show 0 volt, 0 volt DC. If this positive lead is completely grounded, then in that condition this multimeter will show the 0 volt theoretically. Okay, somewhere there will be a partial ground, it will not be completely ground. In that case it will not show complete 0 volt, it will show 5 volt, 10 volt positive, or it may show 55 volt positive. Okay, this may show anything practically if you measure. So it depends upon the wire condition, that how it touch the ground. Okay, so the same thing if it happens with the negative wire, if this negative wire directly ground, then in that condition also it will show minus 0 volt DC. Okay, so here you found by this way that there is a fault in this positive lead, or there is a fault in this negative lead. So if you have identified that there is a fault in this or this, then you have to go further. Then how would you go further? For an example, just take an example. This is the I have taken an example of this isolator magnet box. Then in that you can see that here it is multimeter, the contactor is there, auxiliary switches are there. Here see, three-phase induction motor is there. This is the auxiliary switch using which the indication of the isolator is through up to the panel. You are checking the indication whether it is in closed condition, it is in open condition, or like that. Okay, so this is also it is like a rotary switch, but there will be some mechanical parts in that also. Okay, so the fault might be there in this also, because for me, once this occurred, this happened once upon a time when I was finding the earth fault. Then that time I was not able to find out where is the fault, but when we disconnected the two wires of a contact, then that DC system became healthy. Then we found that yeah, there was a problem in this itself. Okay, so this may occur anywhere. Okay, that's why I have taken an example of this isolator. Okay, see here, this is the TV terminal block where the indication circuit will be connected, and the supply circuit will be also connected. This side the contactors and MCV is there. Okay, so like that the things will be there. Okay, so now you found this. Now I will take an example of a schematic drawing of a 400 kV substation, and there I will tell you that how would you find it out. Okay, the step by step we will discuss, okay, in that video. So in this a schematic drawing of 400 kV switchyard, this side it is showing the control and relay panel drawing. Okay, and this is the DCDB. Okay, so this seat is DC distribution circuit. So if you are taking a reference of your 400 kV or 220 kV or 33 kV a schematic drawing control panel, for the control panel, then you have to just take out that DC distribution circuit. There you can understand well what I am going to explain here. Okay, so for an example, just consider this, that here see, here it is DCDB. Okay, right, DC distribution board. Here 220 volt DC supply source one is there. So this positive and negative is going to the control relay panel, that is 403 bay number RP1. That is the name, just leave about that. So this supply, this positive and negative DC supply came into this panel, and this, then in this panel this DCDB is distributed in different circuit. How it is distributed, just I'm going to explain. So this positive and negative, this J1 and J2 is coming here, and see here this MCV1, that is of 25 ampere. Okay, now hereafter this is the main MCV. Okay, now hereafter this positive and negative is going further, and then it is uh, it is distributed here. So it is distributed in first part, that is going to the MCB2 of 20 ampere, and then MCB3 that is of 16 ampere, and then it is coming to MCB4 of 6 ampere, and again next here MCB5 of 6 ampere. Okay, so in 5 circuit here this DC is being distributed. Okay, so the first circuit, see here, this MCB02, if you switch on, then the supply will be through to this CV close and trip coil circuit. Okay, so this positive and negative will be responsible for closing the breaker and for tripping the breaker, and all the associated circuit connected for the circuit breaker like closing and tripping. Okay, and next if you talk about this, then MCB03 16 ampere, this MCB will be feeding supply to the isolator control circuit. Okay, so with this K701 and K702 ferrule, this positive and negative will be traveling to this circuit. Okay, next, so how you have to do it? Okay, just you understood that this circuit is divided into such parts. Okay, how you would just find it out? So suppose the earth fault may be anywhere, maybe in the DCDB itself. So before starting, before going to the other circuit in switch yard, in GIS, or in the ST panel, wherever if you go, then first of all you have to check in the DCDB itself. Okay, just switch off all the output MCB of the DCDB when your system is in shutdown condition, then only in that condition it is allowed to do. Okay, otherwise you take an exam permission from your senior boss in the written form, take a work permit, and then you start this. Okay, the fault might be in the DCTV itself. If it is cleared, then what is the need to go in another circuit? What is the need to tease the other circuit? No need, na. Suppose it is healthy, then you have to go further. Okay, so suppose there is a fault in the circuit breaker circuit. Okay, circuit breaker circuit. So in that condition, in normal healthy condition, if you switch off this MCB, right, this MCB2, and then if you measure the supply here and here or anywhere in the system before it, positive and negative, then you will see that your DC supply became healthy. Okay, that means positive to ground you are getting 110 volt, and negative to ground you are getting 110 volt, and across also you are getting 220 volt, right? So if you are getting, that means your system became healthy. This indicates that there is a problem in the circuit. Okay, as how you switch on this MCB2, then again your DC supply get disturbed. That means it is clarified that there is a problem in the circuit breaker circuit. Okay, likewise, for an example, suppose if you switch off this circuit, that means MCB02, and in that condition also your DC system could not become healthy, then again you switch on this and go further, go for the next MCB, and then check like that. So this time again I checked this MCB03. Okay, MCB03 I switched it off, and then we check the supply here. Okay, then we get that our supply became healthy. That means there is a problem, there is a earth fault in the isolator control circuit. So suppose there is a positive earth fault, positive DC earth fault, then in that condition we are going to take an example of this isolator control circuit. We will go in depth of this control circuit, and then I will show you how to identify that. Okay, so likewise I have just taken an example here to show that in circuit anywhere the fault might be. So you have to just switch on and switch off each and every particular circuit, and then you have to check whether your DC supply became healthy or not. Okay, so let us come to the isolator circuit, and then we will see that how we can rectify. But before that I will suggest you that with work permit only you work anywhere. Before going to touch any circuit in the 400 kV or 220 or in a substation in a control system, you have to ask the question 10 times from yourself that why I am teaching this circuit, why I am touching this circuit. Okay, because touching circuit may cause many problems, because already your system is commissioned. If you are not expert, then just take a help of your senior, take a suggestion from him, and inform to your higher authority also, and then only with proper safety and personal protective equipment, you go and you take action. I will personally suggest you, okay, because without safety and without work permit, I will not suggest to do this. And always do and take this action while there is a shutdown of the particular system in which you are going to do, okay, because in a healthy condition this is not allowed to do, okay. So let us come to the next topic. This example is taken just for reference to show you, and I'm just sharing my practical experience. If you don't have the DC earth fault locator, then you can find this earth fault manually like this, and you can clarify that DC earth fault manually like this, okay. So just so there it was said that you go in the seat number 62, their isolator circuit is there. So we have come in the seat number 62, okay, and here here it is showing here that from seat number 40 this positive case 701 and case 702 is coming, right? So it has come, okay. So now see here, this positive and negative that is shown here in the control and relay panel drawing, that is directly going from relay panel to isolator magnetic box. So here this box represents the isolator magnetic box. Here it is written also here, isolator 40389A, okay. So the name is also given here, okay. So in this in this magnetic box, this positive and negative is coming, okay, here at this point number tv1 and 2, and then this positive and negative is being distributed inside the circuit of the isolator itself. So the fault might be anywhere, okay. I just explained before in the picture that fault might be in the auxiliary switch, fault might be in the tv itself, or many times what happens, the fault might be due to the door only, okay. When you are closing and opening the door of the isolator magnetic box, there itself at the corner the dressing of the wire get cuts, okay, by opening many times, this happens there. Because personally I have seen these things, okay. So for finding the positive and negative came here, you have already found that there is a problem in the circuit of the isolator itself. So now you have to check dedicatedly, you have to check that where is the fault in the isolator now. So each and for particularly each and every isolator circuit and MCB, you have to switch off and switch on, and then you have to find it out. Suppose that in a bay, suppose that there is a bay 401, okay, in a 400 kV there is a bay 401. In that 401 there will be two isolator, one isolator 89A and one another isolator 89B. So for that 89A and 89B, suppose there will be two MCB, then each and every MCB you have to switch on and switch off, and you have to check in which isolator fault is there. So suppose that in 40189A it is found. In this example here it is shown that 40389A, then we will check in this, okay. So here see, this is the interlocking circuit, so fault might be in this interlocking circuit also, okay. The fault might be in this closing and opening circuit also. See here, this is the BCU, bay control unit. So this is giving the close command, this is giving the opening command, okay. So in this wire also fault might be there. So here also you have to divide the circuit, that closing circuit, this opening circuit, this interlocking circuit. For interlocking purpose, the this isolator takes the status of the earth switch also, okay. So there also the fault might be, okay. Here is a very separate circuit, that is the indication circuit. This is the NO contact of the isolator, this is the NC contact of the isolator, and these contacts are being used for close indication in the BCU, and these contacts are being used for the open indication in the BCU, okay. So how this, I just explained you that the fault might be in the auxiliary switch also, okay. So you have to check this circuit also, okay. So individually you have to check each and every circuit, and then you have to find that where is the DCR fault. If it is clear, if it is found, then just clear it and then make the system healthy. Because see, I can share my experience only, okay. I cannot come on your substation and in your control system and then my I can apply my hand to clear that. I'm just sharing my experience. If you don't have the DC earth fault locator, so like this you have to clear. I have taken an example of this isolator. This might be in circuit breaker circuit also, indication circuit also, or any circuit also that is associated in your control system. So if you understood that how to do this, and if you think that this has helped you, please give a comment. I will help you in another way also. Okay, and please don't forget to share this video to your colleagues. Okay, thank you.